Matter can exist in many different forms. Take a piece of ice. It's solid water, and it has a definite structure to it. So while the individual atoms are vibrating at the particle level, at the macroscopic level they do not move around each other. As a result, solids resist any type of stress. It is fairly difficult to change the shape of a solid because of the forces of attraction between the particles. Liquid particles have less of an attraction between them, and so they are able to flow past each other. They do, however, have a pretty good attraction to each other, and so they are still fairly close to one another. Because of this distance, liquids also resist compression. Gases, on the other hand, have a very large distance between their particles. So not only do gases flow, but they are easily compressed. When placed in an open container, gases will escape. If you put the lid on that container and close it down, that gas will become compressed. Well, these are not the only states of matter present in the universe. These are the ones that are most common on Earth, and so those are the ones we're going to focus on. A fluid is then defined as anything that flows. So here on Earth, any liquid or gas is considered a fluid. Density is a physical property of matter. It is an extremely useful characteristic for many reasons, one of which is that it is a defining characteristic. Different substances have different densities. And if you determine the density of a substance, then you can probably figure out what it is. Density is a function of the mass and the volume of a substance. For example, if you take several samples of a substance and determine the mass and volume and graph that data, you will find that there's a linear relationship between the mass and the volume. What this means is that no matter how much of a sample of a substance you have, the density will be the same. The density of a substance can be found by taking the mass of a sample and dividing it by the volume of the sample. Now, since density is a derived unit, the units can change depending on the size of your sample. The SI unit of density is kilograms per cubic meter. In fact, the mass of 1 kilogram was actually defined as the mass of 1,000 milliliters of water. It is common, especially in lab conditions, however, to record the density in grams per cubic centimeter or grams per milliliter. 1 gram per cubic centimeter is equivalent to 1 gram per milliliter, since 1 cubic centimeter is equal volume to 1 milliliter. Both of these would be equivalent to 10 to the third kilograms per meters cubed. So all of those units are the same. This helps gives us a visualization for the old riddle about whether a ton of bricks weighs more than a ton of feathers. Of course, the answer is they both weigh the same, but it is going to take a much larger volume of feathers to reach that ton than it is bricks, because bricks are so much more dense. Suppose a reservoir has a surface area of 50 kilometers squared and an average depth of 40 meters. What mass of water is held behind the dam? We know that density is equal to the mass divided by the volume, so we could rearrange this equation to solve for mass. We can find the volume because we are given the area and the depth of the reservoir. Now we want to make sure that our units are consistent throughout, which they are not. So we want to make sure that we convert our 50 kilometers squared into meters squared. Since there are 10 to the third kilometers in 1 meter, all we have to do is square that and multiply that by our 50 kilometers. So we end up with a volume of 2 times 10 to the 9th meters cubed. The density of water is a value we can look up, and we find that it is 1.00 times 10 to the third kilograms per cubic meter. So all we have to do then is take our density times our volume, and we end up with a mass of 2 times 10 to the 12th kilograms of water in our reservoir.